Good morning, guys. Hope that you're all doing well. Again, it's our first week back to school, so it feels a little weird, but I still wanted to be able to give you guys the same opportunities of having these YouTube videos to rely on in case you guys need extra help. So what we're going to start with now for geometry, the other day we worked with properties of exterior angles. Today we're going to be working with properties of interior angles, right? So what you guys worked on the other day were exterior angles. They were all on the outside of a polygon. And what we know about the exterior angles of any polygon, right? It can have 7 sides, it can have 20 sides, it can have 35 sides. If it's a polygon, the exterior angles will always add up to 360 degrees, always. And the reason it's that is because, again, it makes a full circle when you take all the exterior angles. If you add them all up, it's going to make a circle. That's why it adds up to 360. So regardless of how many sides a polygon has, the exterior angles will always add up to 360 degrees. What we're going to work with today, we're going to work with interior angles. And the interior angles can be a little bit more difficult because it's not the same thing. Whereas exterior angles was always 360 regardless of how many sides, interior angles are different because the more sides it has, the more degrees it's going to add up to. The fewer sides it has, the less it's going to add up to. And it's always dependent on that. So we can look at this, for example. Let's say we have a triangle, right? And the interior angles are all the angles that are inside. If we have a triangle, we know that all the interior angles add up to 180 degrees, right? If we have, let's say, a quadrilateral, right? If we have a quadrilateral, anything with 4 sides, it's always going to add up to 360 degrees, right? And so automatically, right there, we already see it does matter on the sides because the figure that had fewer sides adds up to less. If something has more sides, it's going to add up to more. And then when we have a pentagon, 5 sides, it's going to add up to more, right? So the question is, how do we figure out what it's going to add up to, right? And what this has to do with is the whole idea of triangles, right? We know that a triangle adds up to 180 degrees. And from this, it helps us figure out everything else. Because if we look at this here, this quadrilateral, don't look at it as a quadrilateral. Think of it as 2 triangles, right? We have a triangle here, we have a triangle there. So we know that this is 180, we know that that's 180. So automatically 180 and 180 gives us our 360 degrees that we were talking about, right? So the whole idea of any polygon and the interior angles rests on the triangles, right? The idea of 180, how much a triangle adds up to. So a triangle has 1, that's why it's 180. A quadrilateral, if it has 4 sides, it has 2 triangles, right? So what this is all showing us is that there is a formula that helps us to figure all this out, right? A formula to be able to figure out the sum of the interior angles, right? And it's literally called that, right? Sum of interior angles. In order to figure out what all the interior angles add up to, we apply this formula, right? And what this formula is, it's S equals n minus 2 times 180 degrees, right? And I'm going to explain what this formula actually represents and what it shows, right? So what the S represents, it's the sum. Sum, how much is it all going to add up to? All the interior angles, right? Then we have an N. And I'm going to show you with a quadrilateral, right? Because what a quadrilateral is, it's any figure that has 4 sides, right? 1, 2, 3, 4. What N represents the number of sides. N literally represents the number of sides. How many sides a figure has, right? So if we were talking about a quadrilateral, it would have 4. And it would have 4 because 1, 2, 3, 4 sides, right? S again, S represents the sum. So the only thing you need to know to figure out how much the interior angles are always going to add up to, you just need to use this formula. And what this formula will always tell you is how much all the interior angles will add up to, and all you need to know is just what N is. In this case, N is just how many sides you have, right? And I'm going to show you how to actually use this formula, but if you wanted to do this, for example, if we were using a quadrilateral, we would know that a quadrilateral has 4 sides, so we would substitute N. 4 minus 2 is 2. 2 times 180 gives us our 360. If you wanted to use the idea of a triangle, right? Triangle has 3 sides. 3 minus 2 is 1. 1 times 180 is 180. That's why a triangle always adds up to 180. This formula will show you what all polygons will always add up to. Only thing you ever need to know is how many sides it has, right? And I do want to do an example with this just to be able to show you, right? So let's say we have a polygon, right? Now we want to figure out the sum of the interior angles, right? And I'm going to write the formula out again just for you guys to have it, just so you can refer to it, right? Sum of interior angles. And we know what that formula is. S equals n minus 2 times 180, right? So let's say that we had a pentagon, right? We want to figure out how much the interior angles of this pentagon are going to add up to, right? So in order to figure out what it's going to add up to, the only thing we need to know in that formula is n. In this case, we know that n is 5. And we know it's 5 because 1, 2, 3, 4, 5 sides, right? So since it has 5 sides, we're going to end up substituting, right? We're going to do s equals 5 minus 2 times 180 degrees, right? And all I did, number of sides was 5 sides. 1, 2, 3, 4, 5. So we just substituted n for 5, right? And now once you have this formula, it's just working through it, right? First thing you always do is parentheses. So 5 minus 2 gives us 3, right? So all we did was 5 minus 2 was 3. And now we're going to do 3 times 180 is going to end up giving us 540 degrees. And there's our answer. We know that whenever we have a pentagon is always going to add up to 540 degrees. Because all you ever have to do, it's just substituting n for how many sides we have. In this case, we had 5 sides, so we substituted 5. If you had an octagon has 8 sides, so you would substitute 8. And again, you don't have to memorize all these totals because you can always use this formula. But again, if you can, there's certain ones you can memorize. A triangle will always add up to 180. A quadrilateral, 4 sides will always add up to 360. And we're going to work with quadrilaterals next week a lot, okay? So that's the formula for sum of interior angles. And the one thing I did want you guys to focus on is this. What that 3 represents is how many triangles this pentagon would have. So if you were to look at it this way, is basically we can break up this pentagon into 1, 2, 3 triangles. That's what that 3 represents. Just wanted to show you. Since this is 180 degrees, that's 180, that's 180. Add them all up, gives us 540, right? So that's how we use the formula to figure out the sum of the interior angles. Now I want to show you how we can use this formula to be able to figure out how many sides a shape has if we know how much the interior angles add up to, right? So again, what I'm going to show you, we have the formula, right? S equals n minus 2 times 180. Let's say now, instead of me telling you how many sides we have, I'm going to tell you how much a polygon adds up to, right? So here I'm going to tell you that we have a sum that adds up to 720 degrees, right? We know that the sum is equal to 720 degrees. We want to figure out now how many sides that shape would have, how many sides that polygon would have. So before we had number of sides, we figured out the sum. Now we're going to do backwards. We have the sum, we want to figure out how many sides we're going to have. And all we have to do, again, is substitute. We know that S is equal to 720. So instead of writing S, we would write 720, right? So I'm going to write 720 equals, now I'm just going to substitute everything else, n minus 2 times 180, right? So all I did right there, I took sum and I substituted it for S, right? S was 720, so I just substituted 720 there and then rewrote the rest of the formula there. We want to solve for n, right? So anything that's here with n, we save for last. First thing we can do, let's get rid of that 180. Because again, our goal is to get n by itself. Anything with n is always last. So the first thing we can do is get rid of that 180. Since we have parentheses and a number next to it, whenever we have a number next to parentheses, that's multiplication. In order to get rid of that 180, we have to do the opposite, right? So the opposite of multiplication is division. Divide this by 180, divide this by 180, right? And again, we're dividing because Whenever you have a number next to parentheses, that's multiplication. Opposite of multiplication is division. So we're going to cancel out those two 180s. And now we have that 720 divided by 180 gives us 4, right? All we did was just divide. So we have 4 equals, now n minus 2 is all we have left. Because again, how to solve for n, we want to get n by itself. To get n by itself, let's get rid of that 2. Opposite of subtraction is addition. So add 2 there, add 2 here. The 2's cancel out, and we're left with n equals 6. And we got 6 because 4 plus 2 is 6. And what this means is a polygon with 6 sides will add up to 720 degrees. And if you wanted to, you can check it again, because we would do 6 minus 2 is 4. 4 times 180, 720. Tells us it's right. Let's try another one, just so you guys get comfortable, right? Same thing with this. It's a lot easier when they ask you just to figure out the sum, but in order to figure out the number of sides, it's just working backwards, right? Let's say that now we had a sum of 1,260 degrees. All the interior angles of a polygon adds up to 1,260. We want to figure out the number of sides, right? We want to know how many sides this polygon would have that adds up to 1260, right? Same idea. We're going to use that formula, right? Substitute. So instead of writing S, we're going to substitute 1260, right? So instead of S, we're going to write 1,260. And now, we write everything else. N minus 2 times 180 degrees, right? So all I did in this formula, I just substituted what the sum was. The sum was 1,260. We want to solve for n, right? Same thing we did before. Get n by itself. We want to get rid of everything that's not with n to begin with, right? So 180, whenever it's next to parentheses, it's multiplication. Opposite of multiplication is division. So divide this by 180, divide this by 180, right? The 180s cancel out. So we know that 1,260 divided by 180 is going to give us 7. And again, all I did to get 7 was 1,260 divided by 180 gave us 7. And now just rewrite what's left over equals n minus 2. Now, to get n by itself, we want to get rid of that 2. Opposite of subtraction is addition. Add 2 here. And if I add 2 to one side, I got to add 2 to the other side. Those 2 cancel out. And we're left with n equals 7 plus 2 is 9. There's our answer. We know that a polygon with 9 sides will add up to 1,260. And again, if you wanted to check it to make sure that you're right, we can just take it and substitute it, right? We can do literally S equals 9 minus 2 times 180, right? Just substituting it there. Okay. Just again, this is just check. 9 minus 2 is 7, right? 7 times 180 would end up giving us 1,260, which tells us that our answers match. It's right. So again, guys, just get comfortable in knowing the formula for sum of interior angles. It will always help you out. Again, it's a process. You got to work through it, but it's not difficult. And just remember, exterior angles a lot easier. Exterior angles will always add up to 360. But when it comes to interior, it depends on how many sides you have. If you have any questions, feel free to ask. Take care, guys.